force F is parallel to the inclined plane as shown in the diagram below. So when it says rough incline, it's when the word rough simply means there is friction. There is friction that is present. And then the word constant speed, it simply means that the acceleration is equals to 0, and the net force is therefore equals to 0. So before we dive into a question, you have to ensure that you've extracted all the information that is contained in the statement. And then let us go to number B. So number B, it's asked us to draw a free body diagram showing all the forces that are acting on block B, on block P, I mean. So number one, we have the normal force, which is the force that is exerted by the surface. And then we have the weight, which is acting down. And then we have the applied force, which is F, and this is N. And then we have the frictional force, since the surface is rough. And then we go to C. So C says calculate the magnitude of force F. So before we dive into the calculations of F, there's one thing that you need to understand, is that this force, the weights, it's at an angle with regards to the surface. And the components, or the equivalent components of the resultant force W, we have W parallel and W perpendicular. And these forces are given by W parallel is equal to mg sine theta, and W perpendicular is equal to mg cos theta. So this is important to understand. So let us apply Newton's second law, which says F net is equal to ma. And then from our statement, we were told that the velocity is constant, and therefore the acceleration is constant. So we can say that F net is equals to 0. And then F net is composed of which forces? So there are two forces that are acting here. Three actually. It's the force that is applied, and the frictional force, which is acting on the opposite direction with respect to the force that is applied. And we're gonna have the parallel gravitational force, which is also going to be acting on the opposite direction to the force that is applied. So let us write this down. So you're gonna have the force that is applied minus the frictional force minus the parallel component of the weight. And we're interested in finding F. So F is equals to FF plus WG parallel. And then we are told that the frictional force is 20.37, and the parallel component is nothing but mg sine theta. So 20.37 plus 8, which is the mass of the block, and 9.8 is the gravitational acceleration. And then we have sine 30, and then if we calculate this, it's 20.37 plus 8 times 9.8 sine 30. It equals to 59.57 newtons. Don't forget your units. And then we move to D. So in D, it says force F is now removed, and the block accelerates down the plane. The kinetic force remains as 20.37 newtons. And then it says we need to calculate the magnitude of the acceleration of the block. So let us look at what is happening now. So now this force here is removed, and then the block starts to accelerate downwards. One thing to note is the frictional force now is going to act on the opposite direction, since the force, or since the block is no longer going upwards, it's going downwards. So our new free body diagram would look somewhat like this. We're going to have the weight, and we're going to have the normal force, and we're going to have the frictional force, which will be acting opposite direction. I should remove this. So the frictional force will be acting on the opposite direction. So you're going to have the frictional force. So now the block, since the force applied is removed, now the block is sliding downwards due to the parallel component of gravity. So it's asked us to calculate the magnitude of the acceleration. So we're going to use Newton's second law again, which says F net is equals to ma. And in this case, F net is just the two forces, which is W perpendicular and the frictional force, which acts on the opposite direction, is equals to ma. And then, it's W parallel, not perpendicular. So it's mg sine theta minus ff is equal to ma. And then we know that m is 8 and g is 9, and then sine 30 minus 20.37, which is given to us, is equal to 8a. And then the only unknown is a, and you're going to find a to be 8 times 9.8 sine 30 minus 20.37 is 18.83, and then divided by 8, it's going to be 2.35 meters per second squared.